Greetings from the Hermitage, and welcome to this presentation on solving equations that involve both multiplication and addition. The general form of the equation that we'll be working on is given as ax plus b equals c. Remember that our goal ultimately is to get 1x equals some value. In this equation, the letter A is called the coefficient. B is called a constant. And x is called the unknown value. And our goal is to make the unknown value known. So let's start now with an equation of that form with some numbers instead of letters. And one of the questions that students learning this material initially have is, where do I even start? Well, we have two options to start. We can either, one, zero out the constant, by using the additive inverse. Or option two, use the multiplicative inverse. To make the coefficient equal to 1. Now, one of these starting points makes the solution of this fairly easy, and that's this option number 1. By zeroing out that -5, it just leaves us with a simple multiplication problem. That's by far the easiest thing to do. Option number 2, converting that 3 to a 1. You know how to do that, but it complicates things just a little bit. It's doable, but not nearly as easy as zeroing out that -5. So let's start with option 1, the easy way to go. We'll zero out the -5 first, and then follow through the rest of the solution. To zero out the -5, we'll rewrite this as 3x subtract 5, and the additive inverse says if we add the opposite, And we have to do that to both sides. 16, we're going to add exactly the same value that we did on the left-hand side of the equation. So we'd add a positive 5. The additive inverse says that whenever you make that calculation right there, that's a 0. That's going to leave us with 3x equals 16, add 5. And if I remember right, 16 add 5 is 21. That leaves us with this very simple equation to solve. Not 12, but 21. From the previous presentation on solving multiplication problems, the easy thing to do to keep yourself organized, to go ahead and put every term over 1, and then to convert this 3 into a 1, we multiply by the reciprocal. And we have to do that to both sides. In this step right here, we're employing the multiplicative inverse. The multiplicative inverse always gives us a 1. So that's going to be 1x equals, and then this, when we multiply fractions, remember we go straight across. This equals 21 divided by 3. And then if we factor that 21, we can factor it into a 3 and a 7 right in the denominator. Those cancel out, and now we have 1x equals 7. Once we've done that, it's a good thing for us to check our answer. So we'll do that now. In this case, we have this equation and this equation. Whenever we have two equations like this, these are called systems of equations. You'll see a lot more of that as we go further and further into the academic year. And in this case, all we have to do is take this value of x, which is 7, and put into this equation here. Wherever I see an x in the original equation, I'm going to replace it with a 7. That'll be 3 times 7, subtract 5 equals 16. We'll just simplify the left-hand side. All we have are some numbers. We'll just do the arithmetic. 3 times 7 is 21. Subtract 5, 16. And 21 subtract 5 is 16. Whenever we go through that check process and we get an identity, that's two numbers that are equal to each other, then we know that we've done the solution correctly. Now let's suppose that instead of 7 we got 8, and we're going to check our answer. Once again, this system of equations, all we're going to do is substitute this value of x into this equation. That would be 3 times 8, subtract 5 equals 16. 3 times 8 is 24, subtract 5, and we want to know, does that equal 16? But 24 subtract 5 is 19. 19 does not equal 16, so that would tell us that this value of x is not a solution to the original equation. Now let's look at option number 2. A little bit more complicated, but it can be done. We know from the previous presentation on working with multiplication problems only, and we're going to make that 3 into a 1 to keep ourselves organized. We just put everything over 1 because we're going to be working with fractions. Now we're going to convert this 3 into a 1. But here's where it's a little bit more complicated. Whenever I multiply this equation by the multiplicative inverse of 3 over 1, we have to do that to every term in the equation. So I'm going to put this 1 over 3 out here. And here's a pretty major hint for you. At this point, go ahead and rewrite the equation and put that 1 over 3 in front of every term all the way across. And then do the arithmetic. 1 over 3 times 3 over 1, that's the multiplicative inverse. That gives us a 1x. And then we'll do the arithmetic here. This is going to be 1 subtract 1 over 3 times 5 over 1. Using your rules for multiplying fractions, this would become 5 over 3. And then on the right-hand side, we'd have 16 over 3. Now we have the 1x, but we still have this constant. Now this is just an addition-subtraction problem. We need to zero out this 5/3. To zero him out, rewrite the equation. 1x minus 5 over 3, add the opposite. And since we added 5/3 to the left-hand side of the equal sign, we'll do the same thing to the other side. We'd have 16 over 3 plus 5 over 3. I'll do this arithmetic right now. 16 plus 5. Remember to add fractions. You have to have a common denominator. Our common denominator here is 3, so we're okay with that. And once we have a common denominator, we just add the numerators. That'd be 16 plus 5 is 21. And then this 21 divided by 3 equals 7. This was the additive inverse. That's a 0. So at the end of this, we have 1x equals 7, just like we did previously, doing it the easy way. Now, it's your choice. Whenever you're doing these problems, you can either start with the minus 5, getting rid of the constant. That's by far the easiest thing to do. Or you can use the multiplicative inverse to get a 1 on the unknown value. But to do that, you have to multiply every term in the equation. That's a lot to remember, a lot of opportunities to make mistakes. I highly recommend that you don't use this technique, but you're more than welcome to. Your choice. It's a nice thing about math. There are a lot of different ways to get the answer. So in summary, the general form of the equation that we're working with is ax plus b equals c. To start off, you have two options. Option 1 is to use the additive inverse to zero out that constant term. That means you just add the opposite. And to maintain the equality, you have to add exactly the same thing on the other side. And then that just leaves you with a simple multiplication problem. And you know how to do that. You multiply by the multiplicative inverse, and you get x equals, in this case, c minus b over a. Option number 2 was difficult, but doable. I won't summarize that here. You can go back and look at it if you really insist on doing it that way. By far the easiest thing to do is this. So that pretty much wraps it up. And at the end of the day, there's only one thing left to say. You know what that is? That's all, folks. See if I can spell folks right. Thanks for watching. Thanks for learning. Be safe. Con cuidado.